Now you understand Torricelli's experiment. Okay, now what is the experiment? Let's look into it. See, first is you are going to have this particular experimental setup. Now here what you have? You have mercury. See the test tube? Generally we have 1 meter. Okay, 1 meter is the length and cross-sectional area is unit cross-sectional area. Alright, and this is filled with pure dry mercury completely. Alright, completely you are going to fill it up. Then what you do? Close the test tube with your thumb finger, invert it, and you're going to put it in a beaker or in a trough, which is also filled with pure and dry mercury. Understood? So you're going to invert the test tube, you're going to immerse it in that particular trough. Alright? Now what you have, remember this is 1 meter, isn't it? In this particular 1 meter. Now what happens? Once you are going to immerse it, invert it and then you are going to immerse it. Then what happens? The mercury is going to fall down and it's going to come and circulate. That means mercury is going to create a vacuum on the top of the test tube. This is what we call as Torricellian vacuum. Okay, that is the vacuum created. Now you have mercury and that is coming down and it's stopped. Okay, it is no longer coming down, has stopped. See, if it has to stop, what is the length of this? That is the next point. Now, when measured from the free surface of that particular mercury, free surface is on the trough you have mercury, right? From the free surface, it was found to be 76 centimeter. Alright? It was 1 meter before the mercury level. Now it has reduced to 76 centimeter. Now, what happened here is the most important part. Because mercury is a very heavy metal and mercury is being stopped. In the sense, if mercury is being stopped, there has to be a pressure, which is being applied on mercury to stop it from flowing, correct? Otherwise, mercury would have been, just gone. There has to be some amount of pressure. Now, that pressure is coming from atmosphere. See, this is the atmospheric pressure. Okay, the pressure which is being applied on mercury by the atmosphere. Understood? Now, how do we define this now, or what is the experimental outcome of this one? Observation. We can say that the pressure of the mercury at 76 centimeter, 76 centimeter, mind 76 centimeter is equal to the pressure applied by the atmosphere. Isn't it? Again, I'll repeat this point. It's important. The pressure applied by 76 centimeter height of mercury is equal to the pressure applied by the atmosphere. Okay? Now you have all the values. You have the value of H, rho, G, everything. What is the density of mercury? 13.6 into 10 to the power of 3 kg per meter cube. Correct? G is 9.8 meter per second square. And H is 76 centimeter or 0.76 meter. Now pressure is what? Rho GH. Now this pressure is the atmospheric pressure, isn't it? So PA is equal to rho GH. 13.6 into 10 power 3 into 9.8 into 0.76. If you do it, you will get 1.013 into 10 to the power of 5 Pascal. This is the atmospheric pressure. Understood? Again, that 76 centimeter of that mercury column, whatever you have, the pressure applied by that much amount of mercury is equal to the pressure applied by the atmosphere. Understood? Now, there are a lot of not SI units, I would say. There are not lot of SI units. In SI units, there are two. Newton per meter square or Pascal. Okay, in CGS, you have dyne per centimeter square. There is another way of measuring the pressure. That is millimeter of mercury, mmHg. Thus, generally we use this in calculating the blood pressure. Okay, so BP is measured, right? That is generally in terms of mmHg. Okay, there is one more way of calculating. This is called torr. One torr is 133 Pascal. Okay, this is another way of representing. And there is one more way of understanding and representing pressure. This is generally used in meteorological units. Okay, meteorological department or meteorological experiments. There we use this particular way of measuring pressure, that is bar. One bar is 10 to the power of 5 Pascal. Understood? Now, you know how they say the pressure on the second layer of Jupiter is around 100 bar. This is how they get it. 100 bar is 10 power 7 Pascal. It's a lot of pressure. Understood? So, meteorologically, we use bar. For the medicine purpose, we use mmHg. For SI system, we use Pascal. Alright, these are different units of pressure.